Hey everyone, it's Mr. Russell, and I'm here just to take you through the check-in from 2-1 and 2-3. Okay, this is kind of the first part of your remediation activity, so we'll go through it, and then you'll have a chance to practice some of these skills. Okay, so here was the second example from your check-in. The first one was just asking what the inverse operations were, and we're going to talk about that as we go through the questions here. So this first one, we have x plus 3 equals 9. So our goal, whenever you are asked to solve an equation, is to get x by itself. So if you're looking at this, you have to ask yourself, well, on the left-hand side, we have x plus 3. What do we have to do to isolate the variable, or in this case, to get rid of that plus 3? And so you ask yourself, what is the opposite of adding 3? And the answer to that here would be to subtract 3 from both sides of your equation. So I'm going to subtract 3 from the left-hand side and subtract 3 from the right-hand side. Now, the reason why is if you were to simplify the left-hand side of your equation now, ask yourself, what is 3 minus 3, right? Right there, 3 minus 3 would be 0. So essentially those cancel out, and we're left with just x on the left-hand side. Now, whenever you solve an equation, remember your equation is originally in balance. So the equal sign acts as your balance point, so everything on the left-hand side has to equal everything on the right-hand side. So since we subtracted 3 from the left-hand side to cancel out that 3, we also have to subtract 3 from the right-hand side to keep the equation in balance. So we simplify now. So 9 minus 3 is going to give us 6. Okay, and you can always check your answer by plugging that number back into your equation for x. So I could write it as 6 plus 3. Does that equal 9? And it does. So since I have a true statement, 6 works. Your next question was this: 2/3 x equals 10. Okay, same idea. So we want to get x by itself. So we have to ask ourselves, how do I undo this 2/3 that's being multiplied by x? So we could do it in 2 steps, and that would be to multiply both sides by 3 first, and then to divide by 2. But what we taught you guys in class was to multiply both sides by the reciprocal. And watch how that works. So if I multiply by 3 over 2, okay, again, since I multiplied it by 3 over 2 on the left-hand side, we also have to multiply it by 3 over 2 on the right-hand side. But now let's simplify the left-hand side. So what I could do is multiply my numerators together in our denominators. 3 times 2 is 6. On the bottom, 2 times 3 is also 6. So we would be left with 6 over 6x. And what's 6 divided by 6? Just 1. Okay? But I'm not usually going to write that step out. Instead, what we could do is just cross simplify and say, all right, if I cross simplify these numbers, what is 3 divided by 3? Oh, well, that's 1, right? So those numbers cancel out to just 1. Okay? How about 2? So what's 2 divided by 2? That's also just 1. So by multiplying by the reciprocal, you get your numbers to cancel out to become 1, and you know anything times 1 is itself. So x times 1 now is just x. And then let's simplify the right-hand side. Okay, I'm always looking to cross simplify. So I notice I can divide 10 by 2. 10 divided by 2 would be 5 over 1. So we get 5 times 3, which is 15. Okay, our next question was x over 3 minus 5 equals 2. So now we have a 2-step equation. When you have 2 different operations occurring in your equation, you want to go in the reverse order of operations. Remember, guys, order of operations, we said the phrase GEMNAS. And we use this phrase to simplify an expression, but to solve an equation, we go backwards. So we want to undo any addition and subtraction first, then we undo multiplication, division, and then exponents, and then grouping symbols. So my first step is to undo that subtraction. So again, what's the opposite of subtracting 5? Oh, well, we're going to add 5 to both sides. Okay, and again, now we simplify. So think about what you can combine here together. Since this first term has an x in it, okay, that we can't subtract x over 3 by 5. They're not like terms. But negative 5 plus 5 will cancel out, which will leave us with x over 3 on the left-hand side. And that's going to equal on the right-hand side, 2 plus 5 is 7. Now we are dividing both sides by 3, or we're dividing x by 3. So what's the opposite of dividing? Multiplication. So we're going to multiply both sides by 3. Or you can write it as 3 over 1 if you'd like. Because when you cross simplify here, that 3 cancels out the 3 on the bottom of that fraction, which will leave us with just x, and x is going to equal 21. Okay, question 5. Okay, now we call this a multi-step equation, and this is where we have to simplify on both sides of the equation first. So I want you guys to look at each side individually. And if we just had, let's say, just that expression there, and I said, hey, I want you to simplify that, you would look to combine like terms first. And since these two terms, this 3x and this negative 7x, are on the same side of the equation, we're just going to add together their coefficients. And again, coefficient is the number that's being multiplied by the variable. So the coefficient of this term is 3, and the coefficient of this term is negative 7. So let's combine those together. So 3x minus 7x will leave us with negative 4x. That plus 4 is not a variable term. There's no other terms to combine it with, so I'm going to leave it as just plus 4. Okay, so the left-hand side is simplified. Let's ask ourselves, can we simplify anything on the right-hand side? No, we just have a 20. So let's write equals 20. And now we're going to solve this two-step equation. Our first step, we want to undo the addition first. So we're going to subtract 4 from both sides. Okay. So my 4's will cancel out. We're left with negative 4x equals 16. Let's divide now both sides by negative 4. Because negative 4 is being multiplied by x. Again, the opposite of multiplying, or the inverse of multiplying, is to divide. So that means we're left with x is going to equal negative 4. And our last one, okay, again, we want to simplify both sides first. So in this case here, see how this 2x is inside this grouping symbol? When something's inside a grouping symbol, okay, we can't just combine it with something not in a grouping symbol, okay? Because I have this 3 on the outside, that has to be multiplied into my grouping symbol first. So our first step is to distribute that 3 to both terms inside our parentheses. That's called a distributive property. So 3 times 2x is 6x, 3 times negative 4 is negative 12, and then we still have that minus 5x on the left-hand side, and it equals 16. Now that we simplified that distributive property, now we can combine like terms. So 6x minus 5x will leave us 6 minus 5 is just 1, or we can write that as just x. Okay, and last but not least, let's undo that subtraction. I'm going to add 12 to both sides. So we're left with x equals 16 plus 12 is 28. Okay, so those are your examples from your check-in. Okay, hopefully you're able to see what your mistakes were. Okay, that's the whole idea here. So hopefully you looked at it like, oh, I forgot to distribute there, or maybe the other one you didn't. You multiplied before you subtracted, things like that. So now what you're going to do is you're done with this part of your remediation. I want you to go on Delta Math and now complete the extra examples after this. Okay, and please let your teacher know if you have any questions. Take care, everyone.